Hello everyone. In this video, we will introduce the implementation for stacks and queues. A stack can be built as a special type of list where the elements are accessed, inserted, and deleted only from the end, called the top of the stack. Insert the elements, remove the element, all from the top. Queues. A queue represents a waiting list. A queue can be viewed as a special type of list where the elements are inserted into the end of the queue and are accessed and deleted from the beginning of the queue. So this is the empty queue, add things into the queue, into the queue, into the queue. Now when you remove it, remove it from the beginning. You can use array list to implement the stack and use a linked list to implement the queue. Since insert and delete operation on a stack are met only at the end of the stack, using an array list to implement a stack is more efficient than using a linked list. Since deletion are met at the beginning of the list, it's more efficient to implement a queue using a linked list than using an array list. So if you use this stack to implement, use the array list to implement the stack, and all the stack operations, pop, push, they're going to be all of one time. Use the linked list to implement a queue, and the queue operation in queue and dequeue will be all of one time. There are two ways to design the stack and the queue classes. And one is to use inheritance. So you can define a generic stack that is a subtype of the array list. Generic queue, it's a subtype of linked list. Now the problem with this inheritance is that you're going to inherit unnecessary methods from the super classes. So the best way is to use composition. You can define an array list as a data field in the stack class and use the linked list as a data field in the queue class. So we're going to use this composition to implement stacks and queues. This is the UML diagram for the stack. Get size, peak, pop, push is empty. Use the array list to implement the stack. For the queue, we use the linked list to implement in queue, dequeue, get size. Let's look at the implementation for the queue. This is the class name, generic queue with the type E. We use the linked list to store the data in the queue. This is the in queue. You add the element to the end, and dequeue, you remove the element from the beginning. So all this operation is very efficient. It's all at one time. Please study the details of the code and also look at the test program from this section. And we're going to move on to the next video. Thank you. See you on the next video.